Let's bow our heads as we are going to have an opening prayer. Heavenly Father, we want to thank you once again for this day, for this morning once again, that Father, we have gathered again back to see that Father, we proceed again with this lesson. We appreciate you that you have protected us all throughout the night, and now we are awake, Father, ready for the lesson. And Jehovah, we come before thee, asking for thy mercy, that may you come down and guide us in this session once again, that Father, we might have the understanding. Give us, Lord Jesus Christ, the grace that Father, Lord Jesus Christ, whatsoever we are going to study, Father, that it might be of great importance and that we might understand it, Lord. We also dedicate, Father, our teacher before thee, for the wonderful work, Lord Jesus Christ, that is granting us, Lord. We pray that, Father, may you continue blessing him. And Father, also bless us who are going to be listening. In Jesus Christ's name, I pray and believe. Amen.
Thank you so much, Samuel, for the word of prayer. Good morning, everyone, and you are most welcome for the session. Yesterday, we were looking at vector geometry, and I left you with some work. Some of you have been able to send. I've looked at some of your work, but we are going to build up from there, and we are going to keep doing more in this particular session. However, our major focus in today's session, it's going to be now on the application and how can these questions be set in form of word problems. So that is where we are going to look at, and then we shall build up from there. But also, since this topic also requires us to model things in the physical world, you are going to see that there are some concepts from physics that we are going to apply. So our major area of focus is going to be on application. How do we apply those position vectors, and how do we apply the displacement vectors? Yesterday, we said that a position vector means that that is that particular vector that starts from the origin. And then we said displacement vectors, these ones we shall see them depending on the letters being used, that whenever you find, let me say AB, it means that that vector does not start from the origin, but it just starts from space or from anywhere. So those are the vectors that we are going to look at. And this is going to be our first scenario we are going to look at. They are telling us that at noon, we had two boats. Earlier on, I told you that when we are looking at vectors, one of the applications, it's going to be in transport. Many times you may ask yourself, why is it rare to find that we had maybe an accident on water? Why is it that it's not always easy to hear that maybe we had an accident for planes? The reason is that all those things move using vectors. So always their movements are modeled. So by doing so, they move on specific routes. Unless when someone moves away from the route that was designed, that's when now they can crash in space. Now we have two boats that started their journey at noon. We have boat P and boat Q, and they had position vectors. Now, I'm going to first visualize it in terms of a diagram. We say that when we have, we can first summarize our data, whereby this is our boat. We are going to call this boat P, and we have another boat here, which is boat Q. So whenever you meet such scenarios, the first thing you do, first summarize data, the way it has been given in the scenario. So they are telling you that it had a position vector. One of it was this. This was the position vector for P. When you see the word respectively, it means that the first one applies for the first letter, then the second one applies. So here, the position vector. Now, in vectors, many times when you find position vectors, it is up to you to use which letter you want to use. So sometimes we can use R, not, to represent the position vector. So here it is okay. So I can say that the position vector of P, which we can write as OP, is equal to 4I plus 8J. Then the position vector of Q, which is OQ, is equal to 4i plus 3j. So I'll put an arrow to show that that was the position vector. Then they went on and told that both boats are moving with a constant velocity. The velocity of P is 4i plus j. So I'll come here and I say now the velocity of P is equal to 4i plus j. The velocity of Q is given by 2i plus the 5j. All the distances are in kilometers and the time is measured in hours. And the question is, find the position vectors of P and Q. That was the first question. Then, and PQ after T hours. In other words, they're asking us that where are these particles, where are these boats after a given period of time? That's what they're asking us that. What is the position where these boats are after a given period of time? So that means that we are going to find their position after T hours, that maybe after 5 hours. Where are they? After 3 hours, where were these boats located? So that is what we are going to find. Now, when you look here, you are going to note that in case I use a sketch, this is my sketch. This is where I have 0 as my origin. Now, when I draw roughly 4i and 8j, this can be my 4. Let me say this is 1, this is 2, this is 3, this is 4. Allow me to use 2, 4, 6, and 8. 8 is somewhere there. Now, the first one, if in case I'm to plot, I will have it somewhere here. That initially, this was where the boat was. This was its position from the origin. But from here, then it started moving, but with a constant velocity. Now, you're going to ask yourself, if this was the initial position, this is where P is. This is O to P. But they told that this boat is moving with a constant velocity. Now, if I may ask in the chat, if this boat is to move from this initial position where it was to go on, how can we obtain the distance that it has moved? How do we obtain that distance that it has moved from here up to where it is? In the chat, you tell me which formula. Now, bring back your physics, bring back your physics. That knowledge you had from primary. How do you obtain now the distance that the boat has moved? Put which formula do you think we can use? SPP, Pythagoras. I want you to tell me that from that point where P is to go on, how do you think you are going to obtain that distance? Initially, the boat is here, but they are saying that it is moving with a certain velocity. So if you want to obtain the new distance where it is, how do you think we are going to obtain? I'm looking through the chart. There is a common formula. I'm waiting to, thank you. Yes, yes, Mary, people are getting it. Yes. So, in order for us to get where the particle, this boat P is going to be, we are going to come here and allow me to use this pink. So, maybe it is moving like this. And maybe now it is here. So, in order for us to get the position from P up to where the boat is going to be, we are going to remember that distance will be given by your speed times the time. But since here we are talking about displacement, here we shall not use the speed. Instead, we shall say now velocity. And because they told us velocity is constant, here we shall say that in order for us to get its new displacement, we shall say velocity times the time. So to get the displacement from P up to where the particle is, we are going to say this is the velocity times the time. So now that means that now, in order for us to get its position from the starting point here up to where the new position where it's going to be, it means that I'm going to have to get this distance from the origin, then plus this distance. That's its new position. Members, are you getting it? That in order for me to get the position of P, and you're going to allow me that for the position vector of P at any time t hours, I'm going to add from this point here to here, because they told you position, that means that you start from the origin. So I'm going to start from O to P, then from P up to any point where the particle is by adding on VT. So that means I'm going to, do you allow me to call it RP to represent the position vector of the particle at any point? So I'm going to say, oh, so I'm going to say is equal to OP then plus VT, whereby OP is the initial position where it was, then VT is that displacement it has attained after it has started moving. Kindly let me know whether this one is clear now to everyone in the chat. Let me know whether that is okay. Okay, okay. People are saying yes. Yes. Okay, okay. Okay, some are saying no. Okay, I'm going, let me pardon. Let me pardon. Allow me now to use this screen. Allow me to use this screen. Okay, now I'm going to use here for my sketch. So I have this. Oh, okay. Yeah, I have this. Now, this was the initial position, which was P. This is where the boat was initially. But now the boat has started moving. Now, when it starts moving on water, it will move like that, like that. Now, in order for you to know that like distance is a scalar, and we are dealing with vectors. So in vectors, instead we shall say the displacement. How far has the boat gone after a given period of time? So in order for us to get how far it has gone, that's what we call the displacement. But I want you to relate that displacement is related to velocity. So you know that distance is equal to speed times your time. So in case I'm dealing with displacement, instead I will say it is velocity times the time. Now, for me to get that displacement, the distance it has moved in a given direction from the point where it was up to where it's going to be at any point, it means that I'm going to get the velocity times the time. But if I want to get now its total distance from the origin up to where the boat is here, it means that in vectors, you know, now this is where your boat is here. In order for me to get this pink thing, it means that I'm going to add the distance I'll have from this point up to here, then from here up to here. And now that is what we call the position vector at any point. So the position vector at any point is what I'm calling RP, because this one is representing. So RP will be now O to P, then plus VT, whereby V is the velocity of the particle and T is the time the particle has taken to move there. So in order for you to get from the starting point, an example maybe, okay, to get from the starting point up to where it is at any point on the lake, then this is the formula that we are going to use. Let me hope now it is a bit clear. I'm still dealing with only OP. Members, is it clear? Not yet. Okay, it is okay now. Now, in here the question asked us what is the position vector of P after T hours. So to get P now, I'm going to come and say RP will equal to OP, which was the initial position vector. So this is going to be 4I plus 8J, then plus, feel free to put a bracket first, plus your V, which is the constant velocity of P, which was this. So here I'll come and I say, this is 4I plus J, then times T. Because we don't know the time, so this will equal to 4I plus 8J plus. Now this time multiplies the velocity. So I can have now 40I plus TJ. Members, are we still on the same page? Is that still okay? We shouldn't leave you behind. Okay, Samuel says yes. Alex, yeah. Benjamin, yeah. Okay, Letitia, yes. Okay, okay. Uh-huh. Okay. Now, what are we going to do? We are going to like collect like terms, eh? So you get your i's and the i's. So this is the I and this has I. This has J and J. So of the i's, I'm going to come and say 4I plus 40I. Then plus, I have the J, I'll say 8J plus the TJ. Now, when I reach this point, it means that I'm going to have I and I out, so I can write this as 4 plus 40, everything I, plus here, I can say this is 8 plus T, everything J. And now this is what we call the position vector of the boat P at any time. So in case you want to know where the boat is, for you just say, what time is it? It is 3 hours. You substitute. Then you'll be able to locate where that boat is. That's why when these boats get lost, they first ask themselves, at what time did it leave? That it left at 5.
Mm.
Then they can be able to start now locating that now it left at noon. And what is the time now? It is 1. So it has taken 1 hour. So they will be able to track that now it has moved this distance and this is where it can be at this time. Members, are we good to go for that particular part? Okay, Now, after getting for P, we need to get for Q. So still for Q, still it is the same idea. There's nothing we are going to change. Now, in case we want to get for Q, I can still draw a simple sketch. Now, for Q still, it is the same idea. For Q, it moved 4I3J. So it's like this was its initial position for Q. And then after some time, it moved, this is where it was at first with relation to the origin. So to get any distance it has moved afterwards, we shall also give it times Vt. So in other words, also for Q, we shall say RQ is equal to OQ, then plus Vt.
Okay.
Why don't I allow you to first try it and also get a summary like this of P? So you substitute in what is your OQ, substitute what was its velocity, and then the time. Let me give you some 2 minutes. Everyone first try it out, and then we do it together. Okay, I'm looking through the chat. Okay, Alex has got some answer. RHQ stands for the position vector of Q, of both Q at any point. Martina ya, Patrick ya, Hans ya. Okay, 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 okay. So, now we are going to have our OQ. So the position vector of Q from the question was given like this. So here we shall say this is 4I plus 3J, then plus our velocity, which was given as this. So this is going to be 2I plus 5J, then everything times time. So when you do the mathematics, we shall have 4 plus 2t, everything into I, then plus 3 plus 5t, everything into G. Now, this is the position where the particle, where the boats are after a period or after a given period of time. So up from the origin, this is where the boats are going to be found. Now, when we go on, we are going to ask ourselves, they want us, so we have answered part one, we have answered part two. P and Q. Then the next question wanted us to find, what is PQ? Now, yesterday, we went on and looked at what we call the displacement vectors PQ. And we said, in case I want to put this on graph, oh, I thought I had some space. I don't see space. Thought I had some space here. And the problem, once I remove them, everything is going to disappear. But okay, let me do something here small. Okay, let me do something here small. I think this will help me. Okay. Okay, this will work. Now I'm going to come here and I show it a bit like on a sketch, such that people can see it. Now, what is going to happen, I'm going to use this side, or what is going to happen is this, like this is your kind of sketch. This is your O. So the first particle was P, or the first boat, which was located at this point, and then it started moving like that. Then you had this second boat, which is which is Q. So it started moving like that, and now maybe it is here. So this is where boat P is, and this is where boat Q is. Now they're asking you, what is this displacement here? Here in between P and Q. That is what we are looking at. So we say that in order for us to get PQ, we say that how do we obtain P and Q? So yesterday we learned it, or was it yesterday, in terms of position vectors. So we say that to get PQ, we shall always get now the OQ, then minus OP. But since here we are looking at any time, it means that your OQ is going to be your RQ. Your OP is the same as RP because they want the position vector at any point. So now that's why now instead of me having OQ minus OP, I'm going to have RQ minus RP because those are the position vectors of those boats at any point. So please take note of that. So that means I'm going to come and I will define it again. I'm going to define it that to get my PQ, I'll have my RQ, then minus RP. So, but I have my RQ already from here. So I will say my RQ is the same as 4 plus 2T. Oh, let me write it from these sides. So I will say that my PQ is the same as 4 plus 2T I plus 3 plus 5T J. This is my RQ. Then minus my RP, which is the same as 4 plus 4T I plus 8 plus T J. Now we say that when we are subtracting vectors, we subtract corresponding components. I get the I and the I, the J and the J. So that means we are going to get the I and the I's. So I'll come here and say this is 4 plus 2t I minus 4 plus the 4t of I. That is the first bracket. Then I'm going to have the second one. This is plus. I have this one, which is 3 plus 5t of j minus 8 plus t of j. Members, are we still on the same page? Gilbert says yes. The rest, okay, Alex says, okay, it seems we are on the same page. Okay, now, when we are subtracting, we subtract corresponding components. Yeah, so you cannot see here, let me just do it here, not to show it. Here, you look at this is 4 minus 4. So in case you want, you can open, no problem, and say this is like 4i plus 2ti minus 4i minus 40i, something like that. Then here it's like having 3j plus 5tj minus 8j minus tj. Then you subtract 4i minus 4i. I think that one we end up with as 0. Then you have 2t, I remain with the 2t I minus 40i. Then this side I have 3j minus 8j. Then you say 3 minus 8. What do you get? You remain with negative 5j. Then this is 5tj minus tj. You remain with 4tj. Then here also I would have subtracted 2t minus 40i. I remain with that is what? Negative 2ti. Then minus 5j plus 40j. Something like that. Kindly let me know whether we are obtaining or whether that is very okay to each one of us. Is that still okay? How we are subtracting? Okay, good. Now, when we reach here, we can go on and now have it a bit composed. So by having it a bit composed, helps us. So here I can say this is negative 2ti. Then this one for j, I can combine it because the j and the j. So I want you to check very well. I can first write this positive j and this 5j. Then afterwards, I can say this is negative 2ti, then plus, I can say this is 40 minus 5, everything times j. And I can say this is my PQ. Okay. Hope members that is very clear. So let me allow you to first put that one down before we continue. Because now that is where we end for P and Q. So let me take on some 2 questions. In case you have a question, you may raise up your hand as others take note. In case you have a question. Yes, Ruth?
Teacher, I'm kindly requesting you to re-echo just something, the side of the, what did we call them? We call them position vectors at a certain time t. I don't know why, as the reason as to why we used the RQ and RP as to get PQ. Just
Okay, first keep on. Like these letters of R, RP and RQ, it is up to you to use any letters of your choice. The reason why I did not use OP as my position vector, it is because I had already used it here for the initial. So that's why I did not use it. But what this tells us is that when you are, okay, let me use this black. What is happening is that we have our reference point as the origin. And they told us that this spot was positioned at 4i8j. So this particle already was somewhere. This is where P was at first. This was the initial position, and this is what we called our OP. But when the boat is located at this point, it starts moving. So when it starts moving on water, it will move. Now, your task is that if I want to measure how far this boat has gone, where it is, let me say it is here, from the origin, how do I get that distance without me coming here and here? So that's what we are trying to find out. If I'm to measure from the starting point from the origin up to where the boat is, how do I obtain that? So that is the line we have drawn. And that's what we are calling our RP. That RP is that direct distance that from the origin to any point where the boat will be on water. But in order for us to get this distance from where it was up to where it is at any point, we know that distance is related to speed times time. But since here in vectors, we look at the direction. Instead, we don't use speed, we use velocity. So to get the displacement of the particle at any point, we shall always have the velocity times the time. So that's why here we are saying this is v times t, whereby v is the velocity and t is the time, because we start measuring our time from the point when the boat starts moving. So in order for us to get the position where the particle is at any point, we can apply our vector geometry that I will move from O to P, then from P up to any point where the particle is. So that's why we are adding OP then plus the VT. But VT stands for the position vector, or stands for the displacement vector of the particle from where it was to any point it is, or it is where it is on water.
Okay, thank you, teacher.
Okay. Yes, Bright. All
Good
Bright.
morning, Master.
Yes, good morning.
Yeah, for me, I was just inquiring of whether there is another method of finding the shortest distance between the two position vectors.
We have not reached there, but we are going to look at it.
Okay,
Okay.
thank you.
Okay. Then Afayo. Yes, Ivan.
Morning, sir. Good
Morning.
morning, sir.
Morning.
Now, I'm requesting to show
Oh, I think I'm not getting you.
where that RP, that equal P plus VT. I'm saying root for RP and the R that vector diagram.
I've not gotten you. Your network was a bit off. I didn't pick your question very well. Like your network was off. Oh, okay. I think you can type, eh? You went off, so I was not picking you. Okay. So after here, when you go back to our question now wanted us to show. Okay, I don't want to clean this side. So they told us that hence explains the distance P between boats in terms of T. Now, what we have obtained is PQ, but it's not the distance, because we know now that between the two boats, the position vector is this, but we have not found the distance. So we say that to get the distance, we say that distance is the length is the magnitude. So in order for us to get the distance PQ, we say that always we shall have our x component plus the y component squared. So from here, when you look very well, you notice that your x component is the negative 2t. Your y component is the 40 minus the 5. So our task is to square them. So I'm going to come here and say now our distance PQ will equal to the square root of P, which is negative 2t squared, plus y, which is 40 minus 5t squared. So what you can do, you can first do your side work. There is no problem. I can first do some side work. You say 40 minus 5 squared is the same as 40 minus 5 squared. Okay, let me multiply it like that. Then after you open, in case multiplication, yeah, but in case you know how to do it quickly, it is also okay. Then you open slowly that this is 16t squared minus 4 times the other one, which is 20t minus 20t plus 25. And then you say this will give me 16t squared minus the 40t plus the 25. So, but in case for you know how to do it quickly, it is very okay. Then when you look at the other negative 2t, everything squared, you know that this is negative 2t times negative 2t, which will give you 40 squared. So that is what you have to do such that you open very well. So when I come back here, that means that I'm going to have inside my 40 squared plus everything I have here, which is 16t squared minus the 40t, then plus the 25. So you're going to allow me to remove this one that I was using to show you how to expand those ones. I can remove it. So when I reach here, I collect like terms. So when I collect like terms, 40 squared plus 16t squared will give us a 20t squared. Then minus the 40t, then plus the 25. Now, this is the distance between the two boats. So between P and Q, this is the distance we have. Yeah. Members, let me know through the chat whether we are still there. Okay, we are there. Okay. Yes, Edward, Samuel, and Irina.
Good, good
Yes,
morning, sir.
Morning.
Master, I was following, but like where is the negative 40 coming from?
Did you look at how I expanded the brackets?
I was a bit following, but I don't know where that negative 40 comes from.
Remember you had this, and when you open,
Yes.
you know that you are going to open like this, minus this, not so?
Yes, sir.
So this is 20t minus 20t, then plus 25. So negative 20 minus 20 is where we get the negative 40t.
Okay, thank you so much, sir.
Okay. Samuel?
Yes, thank you, sir. My question is for that quadratic equation you've got at last, which is under the square root sign. Can't we break it down into the smaller two brackets? Then we get one bracket. Like we get one bracket as the square root of that whole quadratic. So maybe our final answer could be the magnitude PQ equaling to one bracket of that quadratic equation without the square root sign.
Okay. Now that one, Samuel, is possible if this is a perfect square. But when you look at it, this is not a perfect square. So you cannot have it in one bracket. Like you cannot have the square root go away because it's not a perfect square. Yeah. Elena?
Morning, teacher.
Morning.
So, okay, I'm a little confused on on the position how we are able to add the distance of position vector OP and then the position vector of where it is now. Like, how is it possible for us to add OP, which is a position vector, and then P up to its, should I say P naught as distance?
Okay, I hope you know that position vector is more or less like the displacement of the particle from the origin. That is the meaning of position vector. That is where the point, that is the displacement. So what we are adding was also displacement. So we are adding displacement plus displacement.
Oh, okay. Thank you so much, teacher.
Okay. Lugemwa?
Thank you, sir.
Okay.
Teacher, my inquiry is this part where we are square, like when we are finding the magnitude, yeah? Why can this square root sign cancel out with a squared thing in his inside?
Oh, no, now they cannot cancel. Reason being that there is an addition. When you check here, you notice that there is an addition. There is an addition here, so they cannot cancel. That you are adding these two components, so you cannot just cancel like that. But if it was just like this, then this is okay. But since there is another addition, then you cannot cancel them.
Oh, okay, sir.
Okay. Now, this is part B. Then the last part, they want us to show that the minimum distance, or what we call the least distance, is root of 5 kilometers. And remember, they told us these things were in kilometers. So please, you go on and put the kilometers. You go on and put the kilometers. Now, that is where now you are going to apply your knowledge about minimum and maximum. When you look at the distance we have, you notice that inside here, this is a quadratic equation. Earlier on, when you were covering quadratic equations, you looked at what we call the maximum and you looked at what we call the minimum. And we say that under those conditions, you can, in order for you to find the maximum, to find the least or the minimum distance or the minimum point of any quadratic equation, you had something you are following. So I'm going to just remind you of the two approaches, and then you will choose which approach to use. So allow me to remove this screen here because I want to use this space. But I'm just reminding you, and we are picking it from the first topics you covered when you are looking at quadratics. I think that was in first term. Yeah, that's where we are picking it. So let me use this space. So earlier on, you learned that whenever you have a quadratic equation, this is a quadratic equation, bx plus c. You learned that you have what you call the minimum and you have what you call the maximum. And we say that minimum, those are the curves that look like that. And then we said for maximum, the curves will always look like that. And what determines that is the coefficient on x squared. That whenever you have this a, when your a is greater than 0, then we shall always know that you are going to obtain a point that is minima. When you have a point where a is less than 0, then it means that you are going to get a curve like this. In other words, whenever this coefficient is negative, you get a curve of this nature. Whenever this coefficient is positive, you get a curve of this nature. Now, if this is my 1 and this is 2, I want people in the chat to quickly tell me which curve on the 2, if we draw this graph, we shall get. Are we getting 1 or we are getting 2? Put your answer in the chat. Which one do you think we are getting? Just say 1, 2. Very wise people. Yeah, we are going to get 1. That's why the question is asking, what is the minimum distance? Very good. Then you went on. So I'm going to remove this one and I remain with that. Allow me also to remove. You went on and said that in order for you to find that minimum thing, you have two ways to do it. Okay, there are three. You can use differentiation when you reached differentiation. You can use the other condition, but also you looked at what you call completing squares. You looked at a concept of completing squares. And we say that under completing squares, that if you have your quadratic equation, y is equal to ax squared plus bx plus c, for you to get that minimum point, you have to express your equation or your expression in this form. Something like this. That's what you learned. And you say that whenever something is minimum, or what you call the least value, is obtained when your x minus p is equal to 0. That's what you said. That in order for you to get this point here, that point here down, this point here, to get this minimum point here, it only happens when your x minus p squared is equal to 0. And that one can be obtained when you express your expression in terms of by completing squares. Do we remember completing squares? Tell me yes or no in the chat. Do we remember how to complete squares? Gilbert has said no. Imran has said no. Oh, okay. There is a big no in the chat. We can first remind ourselves. Now, when I have x squared plus 10x plus 21. We are going to first use this. This is the first one I'm going to use. Now, when we are completing squares, I'm going to just teach you a summary. The first thing you have to identify, this is our standard quadratic equation. Identify what is my a. That my a is a 1. What is my b? My b is 10. And what is my c? My c is 21. That is the first thing you identify. After identifying that, completing squares, I'm going to give you a summary. What do? You get this original thing here. When we are completing squares, the major thing you need to know is you get your b out of the 2a, but everything squared. This is going to be the concept we are going to use. I'm going to come here. So I'm going to come and say this is x squared plus 10x plus, I'm going to put here my b out of the 2a, everything squared, minus b out of 2a, everything squared. I add on the 21. Now, this is what is going to help us to complete squares. And when you look at our equation, I have not changed anything. For you, add b out of 2a, everything squared, subtract b out of 2a, everything squared. Now, you substitute what your b is and what your a is. So now I'm going to come here and I say, this is x squared plus 10x plus, what is my b out of 2a? My b is 10 out of 2 times 1, everything squared, minus my 10 out of 2 times 1, everything squared, plus 21. When I continue, I will say this is x squared plus 10x plus, inside here I'll have 10 out of 2, I'll have 5, everything squared, minus 5, everything squared, plus 21. Now what you do, members, I want you always, don't struggle with the finding that this is a complete square. I want you always get this x and this 5, combine them. When you look at this 5, here there is a positive sign. So for me, what I do, I'll get this x and a 5, everything I square. So I'll say x plus 5, everything squared. Now the whole of this will vanish. And then I'm going to remain with this. And I'll say this is minus 5 squared is 25 plus 21. And therefore, I remain with x plus 5, everything squared. Minus 25 plus 21, I'll get 4. And that will be my answer. Kindly let me know whether we are on the same page or not. Kinda. Okay. Okay, Yes, Martina. Oh, let me. Martina, go on.
So, teacher,
Yes.
why are we combining x squared and positive 5 squared, and then we're ignoring the 10x? If you could explain, please.
Okay, Martina, you are going to first expand for me this. Martina, expand for me these two brackets. What do we get? Up your hand is. Martina, come again. I want us to expand them.
Okay. Okay, teacher, I think I'm using the mathematical eye. I think we get x squared
Uh-huh.
plus 5
x
Uh-huh.
Plus 25.
Plus 25. I think this is supposed to be 10, Martina.
Oh,
Plus
okay.
25.
Yes.
Not so?
Yes.
Yes. Now, when you look at x plus 5, x plus 5, do you notice that is the same as x plus 5 everything squared?
Yes.
Yes. Now, when you come back here, Martina, here, look at this part here. Are you seeing this part?
Yes.
So that part, you notice that is the same as x squared plus 10x plus 5 squared, right?
Yes.
And when you simplify further, you get this plus 25.
Okay. It has
Eh,
made sense.
Okay. So your aim is to move from here to come here.
Okay.
So when you are with the time, you'll find out that if you leave it here, sometimes it may take you some time for you to be able to discover that this same thing is the same as x plus 5 everything squared. Okay. Members, are we on the same page? Okay, Gilbert says yes. Okay, let me now first put another one, another one, and we try. Remember, we have not even answered our question. We are just reminding ourselves about completing squares first. Because for us to be able to do this number, at least we must know that idea. We must have that idea with us. Another one, I want to just give you a quick one such that we test. I have x squared minus 2x then plus 5. Members, still you do the same thing. Identify what is your A. A is 1. What is your B? Is negative 2. What is your C? Your C is 5. So your task is to find out what is B out of 2A. It is okay for you to first even do it as side work. Then you say that my B is negative 2 out of 2 times 1. Now, what do you do? But remember, I have told you this one must be squared. So this will equal to negative 1 everything squared. But now, this is why I want you to take note that in case you find it is negative, don't square it. First take it. Don't say, this answer is 1. No, take it the way it is. So I will come here and say x squared minus 2x then plus negative 1 squared minus negative 1 squared plus 5. Like I've told you, for you what you do, you come, in case it is negative, carry it the way it is, carry these two the way they are. And say now, inside here I have minus 1. So I say x minus 1 everything squared. Then after, bring what you have this side and say this is minus. Now you can square. Negative 1 squared is 1, then plus 5. And therefore you end up with x minus 1 squared, then plus 4. And then you'd have completed the squares. Yeah, tell me whether we are there. Tell me whether you are. Okay, we are there. Okay, why don't I give you at least one number and then we check ourselves a bit. I'm going to Okay, let me give you one and then you call for me your answer in the chat and then we see at least whether we have picked the idea. You put for me what you have got when you expand. It is here. Let me use this red. Let me now give you x squared minus 4x minus 12. So do this one quickly. I want it in this format here. Audrey, remember your aim is not to change the equation. So when you have Audrey, when you have a squared plus a squared, here you get your answer as 2a squared. But when we have a squared minus a of squared, our answer here is 0. So your aim is not to change anything, is not to change anything. So it's not to change. So we are not changing the equation. So what adding and subtracting makes it 0. So you have not changed anything on the equation. So first do this one, and then we are going to look at another one. I want to give you another one when the coefficient on x squared is not a 0, it's not a 1. Let me hope, Audrey, that is okay. Now here we are expressing by completing squares, so there is no need why we get. And remember, in order for you to get the values of x can only happen when your equation is equated to 0. Otherwise, there is no way we can go beyond that point. Okay, I'm seeing some answers coming in the chat. Okay. Some people have 16. Desire has 28. Desire, can you check out and see? Your answer tends to be different from your friends. Okay. Someone will check out that plus. Someone will check out the plus. Okay. Lugema also check out that 4 and 18. Something is not okay. Remember, at the end of the day, what you have remained with, once you expand it, it must take you back the other side. It must take you back the other side. So I want to agree with people who are getting minus 16. I want to agree with those that we are on the right track. Yes. Okay, Jovis, I think you have forgotten the squared. Just see it is okay. Dorcas, yeah. Okay. Yeah, at least I'm saying people have picked. Now, I want to go to the second part. What if, okay, maybe even now at this point, Now, in case you find such numbers and they're asking you to get the minimum point. So here, what happened is that the moment you reach this point, at minimum point, you just say x minus 1 squared is equal to 0. So this one dies. So your minimum point remains 4. So your answer becomes 4. Now, what if the coefficient is not is not 1, the coefficient of a? What do you do? Now, take an example. I'm going to first give you a hint. Let me say I have 3x squared plus 11x plus 6. And we want to complete squares. Now, I will always advise the first thing you do. Are you seeing this coefficient that is not 1? First remove it. How do we remove it? I will factorize it out. So once I factorize it out like this, it means that every other digit is going to be affected. So this means that when I remove it, it means that I have 3x squared out of 3 plus 11x out of 3 plus 6 out of 3. That is the meaning. So this one and this one can cancel. So that means I'll get 3 into x squared plus 11 out of 3x, then plus, if this one can reduce, it is okay. 6 out of 3 is 2. Members, can you let me know through the chat whether you have picked this step here? Is that step fine? So the moment you open, you must be able to get the original thing. The moment you open, you must be able to get the original thing. Now, what you do, this thing inside, you apply the normal thing we have been applying. Then this thing, apply the normal thing we have been doing. So for you deal with what is inside now. At a later time, that's when you should bring in the 3. Can now everyone first do this one, the way we have been doing normally, and get that thing in square? Yes. Why have we factorized? Is that we don't want this coefficient to be there, such that our work is made easier. Because the moment this coefficient on x squared is not 1, your work may become a bit hard. So that's why we first factorize it out, such that we remain with a complete expression without the coefficient. Hope, Joyce, that is okay. Yes, Matov, we have divided 3 throughout. But remember, this is not an equation. This is an expression. This is an expression. So the 3 cannot go away. Please take note that having 3x squared plus 11x plus 6 equals to 0. Here you can divide by 3 and it dies because this is an equation. But in case it is an expression, that 3 cannot die away. Take note of the difference. Those two things are totally different. Yeah, so hope Imran, you have got the difference here. So you don't just divide through. That 3 disappears if this is an equation. Like equation means you have equated to 0. If it's not equated to 0, it cannot die away. Yeah. So I'm expecting you now to factorize for me this. Shiba, can we change the fraction to a decimal? Very good question. Shiba, work with the fraction. You need to be very, very accurate. Work with the fraction. Work with the fraction the way it is. It is rather complicated. Yes, yes, Edward, that is true. But here, the only tricky thing is that you are working with fraction. But first do your side work. Say B out of 2A. So this will be your B is going to be 11 out of 3 out of 2 times 1. So this will be giving you 11 out of 3 times 2, which will give you 11 out of 6. So now I expect you that you are going to come here and say, this is 3 into x squared plus 11 out of 3x plus 11 out of 6, everything squared minus 11 out of 6, everything squared plus 2. Now your task is just carry these two things inside the bracket. So say this is now, this 3 don't carry it, don't forget it. So this will be x plus 11 out of, out of 6, everything squared, then minus 11 out of 6, everything squared, then plus 2. Something like that. Then after you simplify your work. So this is the knowledge. You studied this in quadratics. That's what you covered it in quadratics. So I'm going to simplify. But I know everyone is trying out. So I expect you to have this. Me here, I can use my calculator to simplify that last part. So here, personal, I'm getting 49 out of 36. Yeah. If you have the same answer with me up to that point, we are on track. You can say, yeah, yes, Dorcas had the same answer. Imran says yes. I'm saying someone here up already had the same answer. Tumini had the same answer. Tutu had the same answer. Audrey, you messed up with those plus things. Miracle had, Ronald had, Patrick had. Yes. Okay. Yes, Audrey.
Teacher, I'm still finding it hard to understand what you mean by the plus or minus. Me, I thought you keep it as a plus.
Okay, Audrey, are you saying this?
When
What am I writing?
remember when you're making it into a perfect square, that 11 out of 6 and a square, me, I put a plus. 11
And
out of
that's where
6.
now, okay, Audrey, are you seeing this equation I've put down?
Yes,
Are you seeing this?
yes,
Are you seeing this? Yes?
yes.
Okay, now, Audrey, if I come and I do like this, let me say I add 1 squared plus 1 squared plus 4. Is this equation the same as the first one before?
No.
No, why?
because you're going to have a plus 2 plus 4
And
giving
you end up with?
A 6.
With 6. What about Audrey? When we put here a minus in between,
Then there it will be a 0.
it will be a 0. So will that equation be the same like the one before?
Yes.
Now that's why we subtract.
Okay. Thank
That
you.
the moment you add, you have changed the equation. You have formulated a new one, but since we don't want to change anything in the equation, so we have to subtract. Okay. So members, those who have obtained up to this point, it means that when we reach at this point here, you can now bring in your 3. You bring in your 3 comfortably. So you say now this is the same as 3x plus 11 out of 6 squared minus. Remember this 3 affects this, also it affects that. So you say this is now 49 out of 36 times the 3. And then this one remains the way it is. Here you can reduce by 3 1 by 3 12. Yeah. So your answer remains like that. Okay, let me pick one hand and then we come back on our question. Yes, Jovix.
Mister, good morning.
Morning.
And the last part here, after the squared brackets, I got 193 over 36, and you have 49 over 36.
Did you subtract well? Did you have negative 121 out of
Yes,
36 plus 2?
yes, that's what I had.
So when you add this one, you get this.
Okay, I ignored the negative, sorry.
Okay, sorry. Okay. So, okay, lastly, Samuel.
My question is, remember you've told us that after the calculations, the final part, you leave this x plus 11 out of 6, and then take the other part of it, which is the negative 49 out of 12 as the minimum. So when you're listing down the minimum answer, do you also take the negative sign?
Yes.
Okay.
Okay, but I'm going to talk about that now. Okay, now let me remove everything, members, and then now we start on our question we are supposed to answer. So Samuel, now there are 2 graphs, you will always encounter 2. Okay, there will be more. There will be more than 2, But when you find that the answer you are getting is negative, it means like this graph you are seeing here, this value here, the y value here is like negative 2. So those are the cases you get. But there are cases where your graph will cut up here, like here. So this you'll find that the answer is positive. So the negative means your curve is below the x-axis. In case you find that you are getting a plus, it means your curve is above the x-axis. Okay. Hope the math is mathing. So now we go to that quadratic equation there. Okay. So I expect people now to have started. We can start and see how to digest. So our equation we have is 20t squared minus 40t plus 25. This is a quadratic equation. And like I've told you, the first thing you have to do before you use completing squares, make sure the coefficient on t is 1. So factorize out to the 20. So I'm going to factorize it and say this is 20. And then I will say this is 20t squared out of 20 minus 40 out of 20t plus 25 out of 20. In other words, the moment you multiply with this 20 you have pulled out, the answer should remain the same. So you notice that this is going to be 20 into t squared minus, this is going to be 2t, then plus 25 out of 20. I think it can be reduced, no problem. You reduce it. 25 divided by 20, you get 5 out of 4. So I can put 5 out of 4, no problem. Let me remove this. And I instead put 5 out of 4. Now, after putting 5 out of 4 members, remember we said you identify what is your A. My A is 1. What is B? My B is -2. So what do we need? We need to get B out of 2A. So when you look very well, you notice this is going to be 2 out of 2 because A is 1. So I remain with -1. Now, when you get -1, we shall come back and say this is 20 into t squared minus 2t, then plus -1 squared minus -1 squared plus 5 out of 4. Members, why don't you first complete for me this thing first? You first complete and we see. First complete and we see what we get.
T squared. Minus 1 squared.
Okay, people read it there. Matia, complete. Matia, complete. Alex, yeah. Yeah. Okay, Alex, there's something you have forgotten. Alex, there is something you have forgotten. KK. KK, there is something that is not adding up where you have that 45. Kindly check out. Kelvin, yeah. Alex, yeah. Chloe, I think Chloe, there is something you're not doing. Something is not adding up. Alia, I've not yet seen your answer. Let me hope things are working out. Agatha, Eke, hope things are working out. Alexis and Alex. Alison, hope things are working out. Aris, hope things are working out. Favor. Asimwe, Audrey, Ayevale, Blessing, Chris, Comfort, Donald, Dina, Diana, hope things are working out. Faith, Gloria, Hannah, hope things are working out. Imran, Jamma Jane, Jeremy Joan. Okay, Letitia Manuela, Martha, Martina, Pavin, Melinda. Okay. I'm seeing some answers in the chat. Okay. Yes, Imran.
Sir, good morning, sir.
Morning.
I'm inquiring whether we do not multiply the t minus 1 squared by the 20.
We multiply it. That 20 affects everything.
So we can open the brackets and then we multiply the 20 inside.
No, after, have you expressed it? Have you expressed this in a square?
Yes.
So you had Hannah, check out that negative quarter. Hannah M. Something is not adding up there. Have you done this, Imran?
Yes.
And here you remain with 1 plus a quarter, something like this, right?
Yes.
So what is -1 plus a quarter?
No, I didn't get -1 plus a quarter.
What did you get?
I got plus a quarter.
So this is 5 out of 4. -1
Yes.
plus 5 out of 4. You got?
I got a quarter.
A quarter. So this is going to be t minus 1 squared plus a quarter, right?
Yes.
So when you bring in the 20, are you noticing that 20 is going to affect this bracket here and this one? So you'll have something like this. I don't know why my thing is not writing well. Then plus 20 out of 4.
Now, my question is, don't we open this other bracket of t minus 1 squared and then
Oh, no
multiply?
need. There is no need why to open.
Okay, so
So this will be 20 t minus 1 squared, then plus here, 20 divided by 4, you get the 5. So this is what I'm expecting you to have.
yes, thank you.
Yeah, okay. Yes, Lugemwa?
Thank you, sir. Cha, I'm requesting you explain to me how you've reached this step of t minus 1 into bracket squared.
Okay. Are you seeing this? Were you around when I was explaining this concept here?
Yeah.
That I just combine the t minus 1, everything squared. Because already when you look at this is already a perfect square. When you have t squared minus 2t plus 1, this is a perfect square, which when you expand, you come up with this.
Okay, thank you, sir.
Okay. Yes, Gilbert?
Yes, good morning, sir.
Morning.
For me, I'm asking under still completing squares. Like, if we are given a number whose coefficient is a negative and that negative is not 1, as we are taking the coefficient outside, do we take it with its negative or we leave it, or we leave the negative with the x squared?
Any approach you want, you can take the negative out or you leave it. All of them, you get the same answer.
Thank you.
Okay. Lastly, Bright.
Yes, Master. Morning.
Morning.
Sir, I a little bit got lost there on that last part. For me, I'm not getting a quote. I'm getting something like 9 out of 4. That last
Now
part
I think
there.
you have ignored the negative. Did you write negative 1 plus 5 out of 4?
No, I wrote 1.
That's where the problem came from. It is negative.
So I take that sign.
Yes, this sign, remember, when you square negative 1 squared here, you get 1. But this negative is still there.
Okay, thank you, sir.
Okay. So, members, we are going to come back here now. Allow me to use this pen now. So when we come back here, now I'm going to part B to that part. So inside here, the bracket, we shall have 20 into t minus 1 squared, then plus 5. Then we know that for least distance or for minimum distance, we know very well that this squared here is equal to 0. So at minimum distance, t minus 1 squared is equal to 0. So what does it mean? It means that everything here vanishes. And therefore, it means that our PQ will remain inside. We shall have, since this one has gone to 0, we shall have the 5 inside. And that's how we prove it. Hope that is okay. Yes, Samuel.
Yes, Master, good morning.
Good morning.
I was just like inquiring from that part of the quadratic where we have the minimum distance or determining the minimum value of the quadratic equation. Is it that it is a mass wherever we get that kind of a square bracket, we equate to a 0 wherever we get it, or it is just for this part only?
Perfect.
Oh.
Whenever they tell you minimum, least, always that squared after using the completing squares will always equal to 0.
Okay, thank you, sir.
In other words, in case you try to draw this graph, in case I'm sketching, that graph will be like this, something like this. But its minimum point will be where 5 is.
Oh. Okay, thank you, sir.
Okay. Lastly, Jovix.
Yes, I have a query.
Mm.
Mostly here, when we get the root of 5, don't we write in decimal points or not required?
Oh, now according to the question we have been handling, are you noticing they told us that show that the least distance between the boat is root of 5 kilometers?
Okay.
Okay, so that's why we are leaving it there. Okay, now members, allow me to show you the second way. Oh, I've removed my thing. Okay, okay. Now the other way, the other approach someone could have used, because we had obtained our distance as root of 20t squared minus 40t plus 25. What another person could have done could have said that my equation, when you look at this quadratic equation, my a is 20, my b is negative 40, and my c is equal to 25. Now, you could get the minimum point, or you could say that at minimum point, or a minimum point is always obtained. A minimum point is always obtained when you have negative b out of 2a. That's how we can get the minimum point, whereby your b is the negative 40. So you can get this is negative 40 divided by this becomes 2 times the 20. So this will give you negative 40. You get 40 out of 40, which will give you, this gives us what? Gives us 1. So what happened is that at minimum point, t is equal to negative b out of 2a. So that means that your t will equal to 1. So once you have 1, it means that when I draw my graph, let me say this is 1. In order for me to get the minimum point, it means that along this axis, I must have 1. Remember, minimum point is like your y value. So what you do after obtaining the 1, you come here in this thing you have remained with, then you set 20 times 1 squared minus 40 times 1 plus 25. When you do the mathematics, this will give you 20 minus 40 plus 25. I'm not sure, but I am very convinced that you'll get 5 inside. So that is the second way you could have done it. Is that fine, members?
Yeah.
Yeah.
If I'm saying pardon, I'm saying that a minimum point can be obtained under this condition here. That when you have t is equal to negative b, or you can say x is equal to negative b out of 2a. To obtain that point, you just say negative b out of 2a. So for you substitute for your quadratic, what is your b and what is your a? Now the answer you get, substitute it in your quadratic equation to get that y value that you are looking for. Yeah, but I wanted you to first show you the other one and then I show you this one. Why? It depends on the question, but all of them can lead you to the same answer. Yes, it is a must. It is a must. Must always be negative b out of 2a. Maximum, the same thing. The only thing that will differ that the moment you substitute, you get different things. Yeah, but that is the approach you can use. Okay, but that is what you covered in quadratics. So allow me now that we proceed to at least another number. Allow me to proceed. Now, this one is your homework. Yeah, this is your homework. At least you take a screenshot. This is your homework. Hope it's not the same. It's not. This is your homework that you are going to do. Remember, we have only done one so far. So this is your homework. This is your homework. Have you finished to take a screenshot? Even graphical method can work for you. Even graphical method can work for you. A graphical method can work for you. Draw your graph and then look at your graph up there and then see where the point is. Even whenever you get these graphs, let me say you have a graph. The moment you want to get this point here, even if your graph is like, as long as you want to get this point, for you just say x is equal to negative b out of 2a. But remember, this one only works for a quadratic equation of degree 2. Of degree 2. Yeah. Even if your graph is like this, for you, as long as you want to get this point where the curve is curving, first get your x, negative b out of 2a. The answer you get, substitute in your equation, then you'll be able to get that point. Okay, people have finished. People have finished. Okay. Okay. I think we look at another one. So read through. First read through. Okay. Hope you have read through. So those who are were in land surveying, those surveyors, when you see them having those instruments, what? There is always, allow me to first throw some light okay, as you read through. This number here, those numbers we have been doing, they can as well be set in a way that they can ask you at what this, like, they can ask you questions like, at what distance should the planes be such that they don't crash? They can ask you in that kind of format that at what distance should the planes be apart such that they don't crash, or the boats. So once they ask you that, indirectly they're asking what is the minimum distance. But also they can ask you at what point is it that the planes crash. So that one is also very possible. But those ones we shall look at them after some time, after we have gone deep into these vectors. Okay. Now, whenever you get these scenarios, first read through and then interpret slowly. Now, when we read through, they are telling us that this person is mapping two locations, A and B, in a three-dimensional space with respect to the origin. The position vector of point A is this, while the position vector of B is this, where t is a real number. Using a vector method supports the surveyor in determining the possible distance between the two locations. You have two locations, A and B, and now you want to know what is the minimum distance between the 2 points. In other words, here they are asking you to first find your AB. After getting AB, find the distance and then look out for the condition. So now here I'm going to say, we know that our AB, the position vector, AB is the same as OB minus OA. Now, from the question, they have given us the position vectors from the origin. So that means that your O to A is the same as 8I minus 6J plus 5K. And they have given us our O to B as TI plus TJ, then plus 2TK. Why don't I first allow you to first get a B in terms of T? Let everyone first try that one. Let us first try on our own and see. Everyone, do it, do it, do it. Okay, I'm looking through the chat to see. Very good. Martina, okay. Alex, no velocity given. Yes, there is no velocity that has been given. Hans, Melinda, Mattia, Joyce. Yeah. Members, I don't know that you allow me to copy the answers the way I'm seeing them here in the chat. Yeah, this is very good. Very good. In case there were vectors that were given velocity, that's when you use it. In case there is nothing, then there is no need why you need to include it. Okay, yeah. Those answers I'm seeing in the chat are correct members. So allow me to just copy. So this is going to be 8 minus t of I plus negative 6 minus t of j, then plus 5 minus 2t of k. T is the time. T, according here, I don't know how they code it, but t is just a number. T is a real number. T is just a real number. So please check out whether this is what you have. Check out whether that's what you have. But I know those people who did BA, I think yours may be a bit different. Just say, I don't know why you have exchanged. People tell me I've exchanged. Okay. Okay. Yes, Ruth?
Teacher, you exchanged the OA and is for OB. So you subtracted OA minus OB instead of OB minus OA.
Oh, okay. So this was okay. I get. Okay, let me change. Yeah, though. Okay. I'm going to let me remove this. Let me remove this. Okay, let me remove this. Okay, paper. Okay, I think this is the one. Let me use this space now instead. People saying I've interchanged. Okay, thank you. So this was OB minus OA. So our OB was TI plus TJ plus 2TK minus OA, which was 8I minus 6J plus 5K. So this was t minus 8I plus t plus 6j plus 2t minus 5k. Members, hope that's what now we have. Now, the other first one I did can also lead you to the right answer. That is BA. But always you read through the question, but you'll get the same answer. Hope now it is okay. Yeah, okay. I think now it is okay. Okay. I think it is now okay. Okay, the standard one, okay, it depends. In case they tell you A to B, then that is okay. In case they tell you B to A, then you have to interchange, Yeah. Audrey, that is okay. Now, this is what we have as our AB. Now, the next thing is to find a distance. So we said find a distance for a 3-dimension. It means we are going to just say x squared plus y squared plus z squared. So members, can you do that? So we have t minus 8 everything squared plus t plus 6 everything squared plus 2t minus 5 everything squared. So members, simplify the brackets, and then I'm going to wait what you remain with inside the bracket. For you simplify, anyone who finishes and you get, you can share with us, and then other members can check out. But simplify it, go step by step. Expand normally, like expand the t minus 8 squared plus the t plus 6 squared, those things in the bracket. Expand normally. Diana. Sajabi has obtained that. Alex has obtained that. Chloe has obtained that. I think Chloe, you're missing a kati there. And those who have finished, okay, Stanley, yeah. Okay, those who have posted their answers in the chat, continue now. Continue and do the number the way I've been doing it. Pause, that's okay. Letitia, check out. Letitia, something is not okay. 125 is okay, but that 8, Letitia, check out. Or chain, go on and collect like terms. Steve, that's okay. Docas, you have forgotten a kati there. there is a T I've forgotten. Nasona, something is not adding 8, that 8T. Nasona, check out that 8T. Okay, Alex. Alex, that's okay. Alex, in case the root can be obtained, you go on and obtain the root. In case that root can be obtained. Alia, that's okay. Imran, Josh, yeah. Yeah, I'm going to just expand here such that those who are not seeing it, they can just compare with what they have. When you expand the first bracket, that's what I expect to have. Martina, that's okay. Melinda, that's okay. Faizo, that's okay. Alison, I've not yet seen your thing. Audrey, check out that 48. Wally, that's okay. Chilo, that's okay. Jen, that's okay. Mattia, that's okay. Those who have challenges, kindly check out here on the screen how I have expanded and then compare with your answer where you might have gone wrong. Abasa, Emma, that's fine. To check out that 101. Something is not adding up. Something is not adding up. Something is not adding up to 2. Something is not adding up. Okay, 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 let me pick a hand. Yes, Martha? Martha?
Master, I'm getting my final answer as the root of 2. I don't know if it is correct.
The root of 2. Now, you remember, have you used completing squares? Which approach have you used?
I've used the one that you say when you have the x or your shortest distance being equaling to negative b over 2a.
What did you get?
I got the root of 2 as my final answer.
Oh, remember, you had to substitute. So this was negative 24 out
Yes,
of
out of 2
12.
times. Yes, out of 12.
So your t became
My t became 2.
2. So you
Oh, master.
substitute.
Okay.
Eh, eh, eh. So when you substitute, I think I saw Alex told us was 89. Was it 89? I'm getting this. This is what I'm seeing. I don't know what other members are getting. Do you check out? For me, this is what I'm getting. Alison, that's okay. Steve is getting the same. Those using completing squares, I expect, yes, that one. Members, are you getting this as well as our minimum distance? That one, yeah. Okay. Hannah, that's okay. Letitia, that's okay. 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 Let me pick on Imran. Yes, Imran.
Excuse me, sir. Inquiring, because according to the question, I'm saying they want us to find the shortest possible distance. Aren't we supposed to be ending on getting the magnitude of AB? Because I think when we continue, we are getting only the minimum distance.
You are saying?
That according to the question, they want us to determine the shortest possible distance between the two locations. And the other one continued and asked us to find the what? The minimum distance. So I'm inquiring whether we can stop on finding the magnitude of
Oh, like
AB.
just stopping here.
Yes.
Oh, now here, because they want the shortest possible distance at any point. So this is the shortest that we can ever have, no matter what value of t it is. So that's why
So
we go up to this point.
we continue, we go ahead and find the
We
value of t.
continue. Yes. But the moment you stop at this point, when someone has a value of t as 5, another one has a value of t as 8, all those people get different answers for the distance. And that is not the minimum what? Distance. So when someone substituting, when you stop at this point, you have not obtained that distance because someone can bring and say, what about when my t is 5? What about my t is equal to 8? What about when my t is this? So it can keep varying. So you have not answered the item.
Okay, sir. Thank you, sir.
Okay. So since here they did not give us the units, you just leave it the way it is. Members, are we good to continue to another number? Are we good? Okay. Oh, people want me to show you the differentiation. Okay, for differentiation, you remember how you got those minimum and maximum things. But that one I think I will talk about it when we reach differentiation. Will the time enable us to finish this? Okay. So we have what we call parallel vectors. Now, whenever they talk about vectors that are parallel, one, as long as a vector is a scalar multiple of the other, in other words, whenever you have that particular vector, which when you multiply, you get exactly the other vector. An example, take an example. In case I have my P as 2i plus 3, so, in case I have my vector P as 2i plus 3j plus maybe 3k, and I have my vector Q as 6i plus 9j plus 9k. Members in the chat, you tell me which value, which when we multiply with vector P, we get exactly Q. Mathematical I. Use the mathematical I. Very good, very good, very good. You notice that that one is a 3. So the moment you can now see that Q is equal to 3 of P. Now these two vectors are called parallel because there is that particular value which when you multiply you get exactly the other vector. So sometimes it can be like this, it can be a fraction, or it can just even be a negative. Yes, that is very possible. So that's what we call parallel vectors. And where do we use these parallel vectors? Parallel vectors are applied when we are trying to find out what we call collinearity. Collinearity means that are the points lying along the same line. Take an example. Whenever they are demarcating a field, whenever you are demarcating land in surveying, whenever you are demarcating something, you want to see, is this thing in line? So in order for you to find whether something is in line, it means that we shall apply that knowledge of parallel because you know that a parallel line is straight. So that is where we apply. Now we have a concept we call collinear points. Collinear points or collinearity means that are they lying on the same line? And whenever they ask you to show collinearity, there are two things you need to take into consideration. That one, those vectors must have a common point. And there must be a point which when you multiply, you get exactly that same point or that same vector. A case in point is that in case this is my line, this is my vector A, this is B, and this is my C. To show collinearity, the only thing you need to do, there are two ways you can do it. One, you can say that vector A to B is a scalar multiple of vector B to C. What is very important is that is there a common point? That yes, that B and B are common points. So that is the first condition that is met. The second condition, is there a scalar multiple? Yes, that there is a value of k, which when you multiply with vector BC, you get exactly a B. So now this is the condition that we are going to be checking out. But still, another person could have done it like he can say AB is equal to scalar multiple of A to C. Also that one is okay, whereby your vector AB and vector AC, as long as there is a common point. So for this case, the common point is what? Is A. So there is a common point and there is a scalar. So whether you do it like this or like this, all of them are correct. But for these particular lessons, I'm going to deal mainly with this part here, like using AB and BC. And I'll tell you at a later time why I loved using that. Members, are we good to continue? And we do one number before our time catches us. Okay. Still, let me start with a scenario. So this is our scenario. They are telling us that we have a planner who's designing a load that must pass through 3 locations. They want to verify whether these points lie on a straight line such that they can be able to build something. Guide the planners whether they should proceed with the construction of the load. That is the first thing. Now, in order for us to guide them, we need to first find out, are these 3 points collinear? That is the first thing we have to do. So sometimes you can first draw them and say, this is point P, this is point Q, and this is point R. And we have said that for collinearity, or for them to be parallel or to be lying on the same line, there must be a common point. And there should be a value, which when you multiply, you get exactly the other point. Now, what are we going to do? So we can use the condition that our vector P to Q is equal to K, Q, R. And I'm going to ask you, do you remember how to get PQ? That yes, we said PQ, you get OQ minus OP. So everyone is going to first get ours OQ minus OP. After getting that, can everyone also get QR by getting OR minus OQ? Can we first try that, everyone? Hmm. Eh, So let's get those two things. We have said parallel vector, ayebale. Parallel vector means that there is a value. Like when you have two vectors, I have vector A and I have vector B. For these two vectors to be parallel, it means that there is a value which when you multiply by another vector, you get exactly that vector, that same vector. Like in case I have vector A and vector B, you can notice that when I multiply a particular value k with this vector B, I get exactly vector A. That is what we call parallel vectors. Someone has got some answer. So I'm also going to come here and subtract. My Q is 3, 1. OP is -3, -2. So for you get your answers, me I will get mine here. and then we compare notes and see. So hope that's what someone is getting. Yeah. Alex, that's okay. Jovix, Tabitha, yeah. I'm seeing the answers coming in. Okay, 2-1. People are getting 2-1 for OR. What is R? R is 5. 5-2 minus OQ, which is 3-1. So this gives us 2 and 1. Members, do we have the same? In case you need some support, raise up your hand before we leave that part. Martina, Ronald, Linda, say Alex. Yeah, those answers are correct. In case you have any question, kindly raise the hand and then we support you before we leave this point. Okay. Okay, I think everyone is okay. So after getting that, we are going to substitute our PQ and KQR. So our PQ was 6-3 is equal to K and QR is 2-1. Now, the moment you reach here, it is up to you either to use the X or to use the Y. So I can use the X components. I can say 6 is equal to 2K. And therefore, my K is equal to 3. In case I had used the second one, still I'll have 3 is equal to K. So that means that our value of K is equal to 3. Now, you have to respond back to the item. They're asking you, guide the planner whether they should proceed with the construction of the load. Remember, the condition was that the 3 points must lie on the same line. So here, who can give us a conclusion? You can raise up the hand and you tell us how you'd conclude, how you'd guide them, and giving a reason. And give a response with a reason. Anyone to tell us how you think you can guide them? Good. Yes, Edward.
So I will give my conclusion. The planners should go on with designing the road, given that all of the 3 locations are collinear and therefore the roads cannot meet.
Okay. Okay. Thank you. Another one. Yes, Samuel.
I would say that the planners continue with the construction of the roads because the 3 roads actually they are collinear since they have the same scalar multiple of 3.
Okay. Thank you, Samuel. Ivan.
Yes, for me, I would say that the planner should go on with the design since the 3 points are collinear and have a common point and with a scalar multiple of 3.
Okay. Thank you. Now, number 1, your answers are okay. Now, always, in case in the question they have used the word straight line, better you stick to that, instead of bringing in collinearity. So here I would expect you to say, the planners should proceed with the construction of the load since the 3 locations P, Q, and R lie along the same or lie along a straight line and have a common point Q where PQ is equal to 3QR, or you can say, and there is a scalar multiple 3, which when you multiply, you get the other, something like that. Yeah, so that's how you can conclude, as long as you have mentioned that they lie along the same straight line, they have a common point, and there is a value or there is a scalar 3, which when you multiply, you get exactly the other vector. And then you state that PQ is equal to 3QR. Yeah, so you can conclude in that way. So you see how you can, but do not forget that they have told you to guide them. So I expect you to say they should proceed because this and that. But if, let me say, if we had subtracted here and maybe take an example here, the values of k for x and y were different, then that means that those loads don't lie along the same straight line. Therefore, they should not proceed. If you had tested the value of x, the k here is 3, the other k is different, then that means that those two loads are not lying along the same straight line. Then part 2, they're asking us that what is the distance between the bus terminal and the shopping mall? Bus terminal and the shopping mall. So when you look at the bus terminal and the shopping mall, bus terminal and shopping mall, that is PQ. So you notice that our vector PQ, we add our answers 6 and 3. So members, what is the distance? Why don't we calculate it? Calculate it. Muzamil also, that is very okay. K stands for the scalar. K stands for how many times do you multiply to get the other. Like it's like the magnification, in other words. I don't know whether Joyce, Joyce, I think you interchanged. Hope you have seen my screen and it is a bit clear. Joyce, you check out. The 3 came about Awori by equating the x component on the right and the x component on the left. So you equate those two corresponding components. Okay. Now they have told us. Okay, I'm reading in the chat. Atuhaire has root of 45. Martina has 3 root 5. Steve has root 45. Root 45, root 45, root 45. Now, we have two answers. Martina is saying is having 3 root 5. Members in the chat are saying root of 45. And the answers told you, leave your answer in a simplified surd. So members, when you look at root 45, is it in a simplified surd or you can simplify further? You should ask yourself. Ziwa, here we are leaving everything in surd form. Faith, that is okay. So people who are having root 45, can we go on and have that answer in its simplified form? Tutu, that's okay, Matt. You can I think it depends on the calc. Those who have the other modern calculators, I know for you, your calculator can do. In case you still have this there are those types of calculators, then for you, please, you go on and say that this is 9 times 9 times 5, and then say now this is 3 root of 5. Yeah, okay. But some calculators, they can give you the answer. Imran, check out, it's not root 45, 3 root 5. Yeah. Okay, yes. Okay, I think the answers are all correct. Members, should we proceed? Those who don't know how we have obtained the distance, we say that distance, you just get the magnitude of x squared plus y squared. So 6 squared plus 3 squared, that is 36 plus 9, which gives us 45. Okay. Members, are we on the same? Esther, have you gotten how we have obtained 45? Esther. Hope, Esther, you have obtained that. Esther, is it fine now? Remember, your PQ was 6 3. So you come here, you say 6 squared plus 3 squared, which will give us 36 plus 9, which will be 45. And when you simplify, you get 3 root 5. Okay, members, is everything fine now? Okay, I have put it. Rachel, is it okay? I've put it down here. Hope you have seen. because they wanted to get. And do not forget, members, when they ask the distance between P and Q, do not forget that to get PQ, you first get OQ minus OP, and then you proceed. Don't get confused with that. Without units, yes, in case there are units, it's okay, you put. In case they have not, you may not commit yourself to any.
Lazarus is
Yeah.
free. Did you hear what I said? Yes.
Okay.
You heard it.
Let me see whether I have another number just for your exercise. Can you put this down just for your exercise and trying out? This is the one you are going to try out. You can just take a screenshot. Finished? Okay. Okay. People said they have finished. Okay. So I think I'm going to stop sharing, and I think we shall start from here tomorrow. Thank you so much.